Hey everyone, so today we're going to be looking at factoring polynomials, okay? So first we're going to be taking a look at a quick flow chart to help you look at the different steps you could take to factoring any given polynomial. So this will be a really good reference point for whenever you're trying to factor a polynomial problem, okay? So let's take a look at the first step. The first step is to greatest common factor. You always want to make sure you do this because it'll make all your other steps so much easier, okay? And we're going to take a look at an example of each of these things. So just remember, if you're a little bit confused right now, don't worry about it. You can take a look at these videos. Second step is to decide what type of polynomial you're dealing with, okay? So what does that mean? First, we have our binomial. That means that our polynomial contains two terms. How do we deal with that? It will be either differences of squares or it cannot be factored, okay? Then we have our trinomial. Our trinomial means that it contains three terms. How do we deal with that? We can do a perfect trinomial square, a regular trinomial, or it cannot be factored. And finally, we have our polynomial. And that means that there are many terms. How do we do that? Well, we group the terms into factorable, binomial, or trinomial groups. Okay, so first we're going to be taking a look at an example of how to greatest common factor in case you were wondering what that even is. Okay, let's take a look over here. So over here I have an example of our greatest common factor. What we're trying to do right now is we're trying to see what's our GCF. So let's see what number is divisible by both these numbers. So 6 could be divided by 3. 9 could also be divided by 3. And that's the highest value that these two numbers can be divided by. So we know that that is one of our factors. So we're going to write 3. Now remember that we can't only just look at the numbers, we have to look at the variables involved as well. And we can see clearly that an x is involved in both of these, specifically x to the exponent 1. So x to the exponent 1 is going to be one of our factors as well. Now, how do we figure out whatever's in our brackets? Well, let's take a look at this. Over here, let's look at our first term that's going to be in our brackets. You're basically doing 6x squared divided by 3x, okay? And what do you get when you do so? Well, 6 divided by 3, you get 2. X squared divided by x, you get x to the exponent 1. Why is it to the exponent 1? Because we look at our exponent rules, which is 2 minus 1, right? And so you get 1 over here. Of course, you don't have to write it. And then let's take a look at our second term in our brackets over here. Here we're given negative 9 xy. We're dividing by 3x. All right, so what does that give us? Negative 9 divided by 3 gives us minus 3. X divided by x is 1 minus 1, which is an exponent of 0, right? 1 minus 1. So you get x to the exponent 0, which is just 1. So we can forget about that. We don't have to write it out. And then we have our y, which cannot be divided by anything. So this is your factored form of this example. You always want to make sure you greatest common factor, no matter what example you are looking at. Now that we took a look at our greatest common factor, what we are going to be doing is looking at our different types of polynomials. So first, we're going to be looking at our binomials, so the differences of squared, and an example where it cannot be factored. So let's first take a look at differences of squares and understand what does that even mean. Now, how can we identify that something is a difference of square? Well, there are 3 requirements that it has to meet, and that involves looking at your first term, which is this 25x squared. It involves looking at the sign between the two terms. And secondly, it involves looking at the second term, okay? So let's do something on the side. Okay, essentially what we're going to be doing is we're going to look at the first term. So let's take a look at term 1. So term 1, essentially what you're finding out is what is the square root of the first term. In this case, the square root of the first term is 5x. Since it's an easy value, it's not like 2.2 something, then we know we're dealing with it's differences of square. It's an integer, right? Okay, now let's take a look at term 2. Term 2 should also just be an integer. So square root of 16, you get a value of 4. Perfect. We're not dealing with any decimal places, any fractions. That's good. So 2 out of the 3 conditions are met. Now we have to look at this sign here. This sign is a subtracting sign, which means that we have met all 3 conditions. So in order for it to be a difference of square, there has to be a subtraction sign. And that makes sense. If you take a look at the name of this type of, problem, it's differences, hence subtracting, of squares, hence square rooting the 2 terms. And that's just an easy way to remember this. Now, how do we set up differences of squares? Well, you have your 2 brackets, and you're going to take these 2 values that we have here. So let me show you all these. You're going to take these 2, and you're going to do this. 5x plus 4. 5x minus 4. So essentially, you've just set up the 5x as the first term in each bracket, and you set up the 4 as the second term in each bracket, with one having a plus sign, one having a subtracting sign. Okay, now how does this work and why does this work? Well, let's take a look by expanding. Okay, so let's expand this out, and this will help you out into understanding why we do this. So 5x times 5x, you get 25x squared. 5x times negative 4, you get minus 20x. 4 times 5x, you get positive 20x. And then finally, 4 times negative 4, you get minus 16. Now, as you can see, having this plus and minus sign between the terms is essential because it causes these 2 values to cancel each other out since these are negatives of each other. They're same value, but negatives. So these 2 cancel out, and you are left with whatever we started with. So 25x squared minus 16. And there you have it. So essentially, if I want to show you what is our factor, it is this over here. Okay, this is how you factor out your differences of squares. Alright, now that we went through the differences of square, we're going to go through a very simple one. This is an example that cannot be factored. So first, we have identified that this is a binomial since it has only 2 terms. So we know it can be only differences of squares, or it can't be factored. Or greatest common factor, of course, you always got to look for that. So as we can see, there's no greatest common factor. There's no number divisible by 2. There's no variables that are present in both of these that are the same. So there is no GCF. Okay? Now let's check if it's differences of square. Well, if we square root 3xy, well, we get a very ugly number, okay? And that's not pretty. So we know already we're not dealing with the differences of square. So I'll just put differences of square. And finally, we know this cannot be factored. Okay, so this essentially tells us that we cannot factor. All right, so that one is pretty straightforward. Remember to always check for GCF and just look what can happen under that type of polynomial. All right, awesome. All right, so that's it for factoring part 1. We took a look at greatest common factor and binomial polynomials. The next video, you're going to be taking a look at trinomials. Thank you for watching.